All right, this is lesson number 2, and you should be on this paper right here. Theoretical versus experimental probability. Theoretical probability is really just saying it's an estimated likelihood of an event occurring based on assumptions about an experiment. Mostly that means that whatever you're doing, that all sides or whatever it is you're doing has an equal and fair chance of occurring. So, for example, flipping a coin. We're basing this theoretically, we're saying what should happen in theory, not necessarily what actually does happen when you flip the coin. So, in theory, if I flip a coin, what's the chance that it's going to land on tails? Well, this is what we did yet or before. There's two different ways it could land, and out of those two, one of them is tails. So I really have a 1/2 or 50% chance of flipping a coin and landing on tails. If I have a number cube, what's the probability of rolling a 4 on a number cube? Well, how many ways could it land? There are 6. Out of those 6, which one is actually a 4? Well, I kind of gave it away. There's only one. So you really have a 1 out of 6 chance of getting a 4. So theoretical probability is really what should happen. Experimental probability is what actually does happen when we try it out for ourselves. So this is based on the results of running an experiment many times. So that's what you're going to do right now. So you're going to pause the video for just a few minutes, go to the back table, get a coin, and get a number cube. You're going to flip your coin 10 different times and record what you get down here. You're going to roll the number cube 12 times and record what you get down below. So go ahead and pause and then take care of that for a few minutes. Okay, so you should have your results, and you can see I already have mine here. So now, based on your 10 flips of the coin, what was your experimental probability, so actually based on what you did, of landing on tails? Well, out of my 10 flips, I actually had 3, that's a terrible 3 tails. So mine would be 3/10 or a 0.3 or 30%. On my rolling of the die or the number cube, I had 12 rolls. And again, fill in yours, not what I'm doing here. What's your experimental probability of rolling a 4? Well, out of 12 rolls, I had 2 4s. So if I simplify that, that is a 1 out of 6 chance, which turns out to be exactly the same as my theoretical probability. So yours might be right on or might be a little bit higher or low, and that's okay. So let's go on to example 1. So what is the theoretical probability of rolling a number less than 5 on a number cube? So not actually doing it, but if we were to do it, what would we expect based on what should happen? Well, there are, again, 6 ways of rolling a number cube. How many different numbers would be less than 5? Well, that would be 4. That would be 3, 2, and 1. So you have a 4 out of 6 chance, and then you need to simplify that, and it would be 2/3. So you have a 2 out of 3 chance of getting a number less than 5. Now, based on yours, what is the experimental probability that you actually got less than 5? So in my case, if I go back and look at what I got, I had 1, 2, 3, 4, 5, 6 numbers that were less than 5. So mine would be 6 out of 12 because there were 12 rolls total. So mine would be 1/2, which is lower than what is actually expected. But the more times I did that experiment, the closer it would get to that 2/3 in most situations. All right, so let's go down to example 2. A game spinner was spun 500 times. It was found that A was spun 170 times, B 244, and C 86. Estimate the probability of the spinner landing on A. So what is your sample space? So how many total times did this spinner get spun? It was 500. Out of those, how many landed on A, which is the event, what we're looking for? That would be 170. Simplify your fraction, you get 17/50. Now, based on that, is that experimental or is that theoretical? Put an E for experimental or a T for theoretical. What do you think this falls into the category of? It would be experimental because we're basing this probability on what actually happened when we did many trials. Okay, let's go to number 3. A researcher has been observing cars passing through an intersection where there's heavy traffic. Of the last 50 cars, 21 turned left, 15 turned right, and 14, that should be went, straight. Estimate the probability that a car will turn right. So pause for a second and do that one on your own. All right, and in this case, we had 50 cars total. We wanted how many turned right, which would be 15. Simplify your fraction. We should have 3/10. And is this experimental or theoretical? And the answer is E for experimental, because it was actually based on observing what actually occurred. All right, let's keep it rolling. Let's go to number 4. Suppose you're playing a game in which 2 fair dice are rolled. Now this is a little different. 2 dice. You need a 7 to land on the finish by an exact count, or a 4 to land on a roll again space. What is the probability of landing on the finish or rolling again? So it also says see below for all outcomes of rolling 2 dice. So if you look down at the bottom of your paper, I gave you a handy dandy little diagram that shows you all the different ways, if you rolled 2 dice, how they could end up. So you have 6 across the top, 6 across the side, a 6 by 6, which means there are 36 total ways. How many ways could we get a 7 or a 4? So I'm going to let you take a gander at those and figure that out. Okay, so you should have found that there was 4, 4, and 4, and then for the 7s, we're right along this diagonal right here. So when you count all those up, you have a total of 9 out of 36. Simplify that, and you get 1/4. So there's a 1 out of 4 chance that you'll either roll a 4 or a 7. Now, is that experimental or theoretical? So is that we ran a bunch of experiments, a bunch of trials, and found out what actually happened, or are we basing it on what should happen? And the answer is what should happen, which means it is theoretical. All right, I'm going to let you do this next one on your own, so pause the video and answer the question for example number 5 and determine if it's experimental or theoretical. All right, so if you looked back at your examples, doubles means 2 of the same number. So we have 1, 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. That is a total of 6 different ways out of 36. Simplify that mug. We get 1/6. Experimental or theoretical, and it is T for theoretical. Because again, we didn't run a bunch of trials and roll a bunch of dice. We are just basing it on what should happen. Okay, there it is in a nutshell. So now I'm going to let you go on to 9B, 9.2b and 9.4b, and I'm actually going to help you with 9.4b, number 11. I already did it. Look at that. So let me erase what I got here, and then we'll go through it again. So this says find the theoretical, so what should happen, probability of having thrown a dart and landing in the indicated area. So let's look. The number 11, the area you want to land in is area 3. So this section right here. Well, what we need to know is how many of those total sections would it take to make up the entire dartboard, for lack of a better word. So we've got one here. We could put another one down here, cut that in half, cut this in half. There's another section that would be the same size as 3. One here, and then so on. So how many total sections of 3s would make up the entire space? 1, 2, 3, 4, 5, 6, 7, and 8. So that means your sample space is 8. But out of those, there's only one that's actually labeled 3. So that means there is a 1 in 8 chance of actually landing on area number 3. All right, everything else, I think you should be A-okay. If you have any questions, let me know. And whatever you do not finish on this is surprise homework. All right, I did it. This one was shorter than the last time. All right. Okay, enjoy. See ya.